Welcome to the deep dive. Today we're looking at something, well, frankly, it sounds like pure science fiction, but it's very real. The sources dig into 3I Atlas. Now, this is only the third interstellar object we've ever spotted, discovered July 1st, 2025. And here's the tension. Is it just a massive, super rare comet, a 1 in 10,000 year fluke? Or is it maybe something else? Evidence of technology visiting us.
Right.
Most astronomers lean towards Comet, but a lot of the evidence just doesn't fit. So our mission today is to unpack those specific anomalies, the things that make experts even whisper about alien tech.
And I think that's the key point. This isn't just, classifying some space rock. It's really forcing everyone, including you listening, to step outside the usual comfort zones. We had to look at the data and ask, what if? What if our assumptions are just wrong? Especially when the observations challenge everything we think we know. It's a pretty critical moment, intellectually speaking.
Okay, let's start with the obvious thing, the first red flag. Its size. Assuming it is a solid object, what are we talking about here?
Well, it's incredibly bright. And based on that brightness, the calculations suggest if you assume it's a solid body, we're looking at a diameter of at least 20 kilometers.
20 kilometers, just to put that in perspective. That's bigger than Manhattan Island. And the sources say roughly twice the size of the asteroid that, wiped out the dinosaurs.
Exactly. That's not just a rock. That's a potential planet-altering object just cruising through.
And that sheer size immediately creates problems statistically, right?
Oh, absolutely. A huge problem.
Yeah.
It's about the extreme rarity. I mean, you model the stuff floating out there between the stars, and the best estimates say interstellar space might deliver a rock that big, moving that fast, maybe once every 10,000 years through our inner solar system. Once.
Hold on. Once every 10,000 years. But we found this one after, less than a decade of really looking?
Precisely. We've only had dedicated surveys scanning for these things since about 2017. This is only number 3. So statistically, finding something this enormous so quickly is, well, it's wildly improbable. It means either our models of interstellar space are completely off, or this object isn't just a random piece of debris following the usual rules.
Okay, that statistical improbability alone is pretty staggering, but you mentioned the size is just the start. The trajectory is where things get really strange.
Yes. This is maybe the most compelling piece for the artificial hypothesis. Its path, it's almost perfectly aligned with the ecliptic plane.
The plane where all the planets orbit the sun.
Exactly. It's aligned to within 5 degrees. Now, if it's just some random object flung in from deep space, the odds of it hitting that narrow plane, they calculated as about 1 in 500.
1 in 500 just for the alignment. But it gets weirder.
It does. Because it's on that plane, its path takes it really close to several planets. Mars, Venus, Jupiter. Now add the timing. Even if you grant the unlikely alignment, the chance of it arriving at the exact time to make these close passes to all 3 of those planets simultaneously, that's calculated at 1 in 20,000.
Wow. 1 in 20,000. On top of the 1 in 500 alignment. On top of the 1 in 10,000 size rarity.
Right. You start stacking these improbable coincidences, and the word coincidence really starts to strain. It reaches a breaking point.
At what point do you just say, okay, this isn't random?
That's the question everyone's grappling with. And then there's the timing of its closest approach to the sun, its perihelion. That happens on October 29th, 2025.
And why does that specific date matter so much?
Because when 3I Atlas makes that closest pass, guess where Earth is?
Uh-oh.
On the exact opposite side of the sun. Completely hidden from our view.
So we can't see it?
No. Lost in the sun's glare. And sources point this out very clearly. The timing is the absolute best moment to perform a maneuver using the sun's gravity.
A gravitational slingshot.
Exactly. The most efficient way to change course. And it happens precisely when we have a total blind spot. Convenient, wouldn't you say?
Yeah. Extremely convenient. Okay, so massive size, statistically impossible frequency, bizarrely perfect trajectory, and a perfectly timed solar pass in our blind spot. What about what it actually looks like? Hubble took pictures, right? If it's a comet, it should have.
Well, a tail.
That's the defining characteristic, yes. Ice and dust boiling off, streaming behind it. But the latest analysis from Hubble shows absolutely zero evidence of a cometary tail, nothing trailing behind it.
No tail.
Yep.
Okay, so strike one against the comet hypothesis.
Yeah.
Big strike.
A very big strike.
Yeah.
But it's not just what's missing, it's what's there.
Yeah.
Instead of a tail behind it, the Hubble data shows this distinct glow in front of the object.
In front. The headlights.
It's exactly how the sources describe it. Headlights. Comets don't have headlights. They have tails. Period.
Okay, that's really weird.
Yeah.
It is. And one more thing, the direction it came from. deep in the Milky Way center, just packed with stars, suggests it's traveled a very, very long way.
So the natural explanations are really starting to fall apart here. And if it does maneuver on October 29th, maybe release smaller things, like some sources suggest.
Then we shift immediately from scientific curiosity to, well, potential crisis management.
Right. And groups like the Galileo Project are already gearing up for that.
They are. They're planning intense observation campaigns, looking for any uptick in UAP activity, unidentified anomalous phenomena, after that October 29th date. They're basically preparing for the possibility that this could be like a mothership using the sun to adjust course and then maybe deploying smaller probes once it's clear of the glare.
Given all this, the size, the path, the headlights, we clearly need better words than just rock or not rock. The sources talk about a new scale.
Yes, the Loeb scale. It's proposed specifically for classifying these interstellar objects. It runs from 0 to 10. It's basically a standardized way to rate how weird something is, how much it deviates from natural explanations.
So what's a 0?
0 is easy. It definitely shows a tail, or it looks just like a regular asteroid or icy body. Totally familiar, easily explained by current science.
And a 10, the maximum O score.
A 10 means it's unambiguously technological. It's maneuvering deliberately, changing course on its own. It has artificial lights. It has a strange, non-natural shape. Or it's transmitting signals. Or maybe it's putting out way more heat than sunlight alone could explain, suggesting like an energy or power source.
So where would 3I Atlas land right now on that scale?
Based on the current evidence. Probably somewhere mid to high.
Yeah.
High enough to demand immediate serious attention and planning.
And this need for planning is becoming urgent, isn't it? We've only found 3 of these things so far, but that's about to change dramatically.
Oh yeah. The Rubin Observatory is coming online soon. Within the next decade, it's expected to find a new interstellar object, not every few years, but every few months.
Every few months. Wow.
So we're going from extreme rarity to, well, not common, but much less rare.
Right.
We absolutely need a strategy now for what we do if one of these scores high on the Loeb scale, a 5, a 7, maybe even close to a 10. Because think about the response time. A radio signal from light years away. We've got potentially centuries to figure it out.
Right.
But something like 3I Atlas, if it's technological,
Yeah.
that's effectively a visitor in our backyard. Decisions have to be made fast based on what it's doing and what it could do.
And any response, any decision, it couldn't be just one country, could it? It would have to be global.
Absolutely.
Yeah.
An interstellar visitor isn't going to care about earthly borders or politics. Any coherent response strategy has to be international from the get-go.
You know, thinking about potential visitors forces us to look back at our own history with a new kind of skepticism, doesn't it?
It really does. If we accept interstellar travel as possible, maybe even happening now, then we have to revisit some fundamental assumptions about Earth's past.
Like what?
We'll take the idea of intelligence insertion. Sounds like pure sci-fi, but
Right.
if advanced tech can travel between stars, is it impossible that some kind of, interstellar gardener visited early Earth and maybe nudged evolution towards intelligence?
Mm-hmm.
It's speculative, sure, but when you're looking at odds like 1 in 20,000 for 3I Atlas's trajectory, maybe you need to broaden the possibilities you're willing to consider. Or think about the dinosaurs. We say a big rock did it 66 million years ago.
Yeah.
What if? What if it wasn't just a random rock? What if it was some giant thing that collided with Earth deliberately, maybe to reset the biological clock?
Okay, that's a wild thought.
It is. But these anomalies, like 3 Atlas, they push us to ask these really profound philosophical questions, not just purely scientific ones.
And this ties into ideas about where life itself came from, the panspermia idea.
Directly, we trace all life on Earth back to Alien, the last universal common ancestor, appeared maybe 4.2 billion years ago, pretty much as soon as Earth was remotely habitable.
But Mars, next door, cooled down earlier, right? About 4.5 billion years ago. And it had water lakes, maybe oceans.
Exactly. Mars was likely habitable before Earth. So the panspermia hypothesis suggests life might have actually started there, on Mars. Then, asteroid impacts blast Martian rocks containing microbes into space, and some of those rocks eventually land on Earth, which we know happens.
Seeding Earth with Martian life.
Precisely. Which means, if true, all of us, everything alive on Earth, we could be descendants of Martians.
So exploring Mars isn't just exploring another planet.
It could literally be us returning to our childhood home, finding our deepest origin. It completely reframes Mars exploration, doesn't it? It's potentially an anthropological dig into our own past.
So we're left with this sharp conflict regarding Three-Eye Atlas. Is it this incredible one-off statistical nightmare, huge, no tail, weird lights, perfect path, hiding behind the sun at the key moment? Or is it the signal flare telling us, okay, time to get the lobe scale ready, figure out global protocols because the visitors might actually be here?
That's the immediate dilemma. But looking beyond Three-Eye Atlas, think about that Mars connection for a moment. If, in the coming years, we find definitive evidence of past or even present life on Mars, and critically, what if that Martian life looks fundamentally like ours? Same basic chemistry, maybe even similar genetic structures. What does that discovery do to the story we tell ourselves about being unique, about life originating solely here on Earth? It suggests our origin story isn't just terrestrial. It might be interplanetary. That's the really big question these discoveries are forcing us all to confront.